Hi, I'm Kelly Flores, and these are the Big Picture Talks. Today, I want to talk about the relationship between words and humans. But first, I want to talk about a particular word before we talk about words in general. And the word I want to talk about is scientist. Because that word is so loaded, and so often we think of a scientist as someone who's working at NASA or studied physics or chemistry, is working on cancer research or biology, and these people are doing loads of math. Scientists are doing loads of math, and all scientists have been to college. And that is kind of a stereotypical, narrow definition of what a scientist is, because a scientist is someone who practices science and uses the scientific method. And by that definition, every single human is a natural-born scientist. And this is why. Because the scientific method is just steps for problem solving. And the first step, it's particular steps. And the first step is to identify a problem or a question. And the second step is to research the problem and then form what's called a hypothesis, which is just a fancy way of saying a prediction or a guess of how you might solve the problem or answer the question. And then the third step is you test your guess. You form an experiment, and the rules in science is that the experiment has to be repeatable, and that another human or person can repeat the experiment and obtain the same results. And the experiment will tell you if you're going to, that's how you find out if you get the results that you guessed at, the results that you predicted in your hypothesis. So you have a question, you research the question and guess at how to solve or answer the question. You test your guess and see what your results are, and supposedly you record your results, but you don't always have to record them, because that's how we learn. We end up just recording it in our own memory. So by that definition, a 3-year-old human is already practicing the scientific method when the cookies are in the cookie jar and the cookie jar's up on the shelf. When the 3-year-old is like, I want a cookie, but I have this problem. The cookie jar's up on the shelf and I can't reach it. I'm not tall enough. So the problem is how to reach the cookies. So the 3-year-old kid looks at a chair and thinks, if I pull the chair over to the counter, I can climb up on the chair, and then I'll be up where the cookies are and I can get the cookies. So the problem was the cookies were up too high. The question, how to get to the cookies. The hypothesis is if I push a chair over there, I can get up to the cookies. And the experiment is to actually push the chair over, get up and get the cookies. And the result is the hypothesis, the guess, the prediction was correct. If I push this chair over here, I can get these cookies. So by the time we're 3 years old, we're practicing the scientific method every time we solve a problem. And even if you look at primitive human beings, or you think about the first person who ever figured out that the seed inside a fruit would grow a tree that would reproduce that fruit. That's a longer experiment. Somewhere along the line, some person maybe was sitting eating fruit and spitting the seeds out, and they knew they were sitting by this rock, and they hang around this area long enough to see that there's little plants starting to grow up by the rock where where she was spitting out the seeds. And she's like, I was sitting there eating that fruit and spitting seeds out there, and now there's little plants there. And then maybe she goes away and gathers berries, if it is, if that's the fruit, if it's berries, and gathers berries somewhere else, and then comes back later and sees that a full mature berry bush is there by the rock where she sat and spit out the seeds, and then she eats the berries again and she's like, there's these seeds in here. So she has already done an experiment just by observing what's happening. She's gotten some research and done a kind of accidental experiment. The problem is, getting food. The question is where to get the berries. And she's looking at this situation and thinking, maybe if I put these berries in the ground on purpose, and maybe if I put them down by the stream where the berries grow really good, put them down there where there's not some berries growing right now, maybe I'll get some nice big berry bushes. So she plants the berry seeds and comes back later, and sure enough, there's berry bushes producing that, the fruit, So the problem and the question was getting food, gathering berries to have something to eat. And, then there's an observation, just like the little kid could see that you can get on a chair and get up higher. There was a previous observation that plants seem to grow where you're spitting out these seeds. And then you come back later and sure enough there's full grown plants there. So, you form your guess that you can put these seeds in the ground and they'll grow plants. So even the primitive people were scientists. Anytime we worked out any problem in a way that could be tested and repeated and get the same results, we've been using the scientific method.